Hello everyone. So in this today's session I will be discussing the basic electronics course, means prerequisite that is required for understanding the basic electronics course of first year engineering, this one. So here I will be recalling the things already you people might be studied in your first PU or in second PU, right? So I will be starting this review of semiconductor theory. So in order to understand the electronics devices very well, so you should have this basic prerequisite of semiconductor theory. Means I will be discussing what is semiconductor, what is insulator, what is conductor, then how this is classification is done. This classification is done based on the conductivity of the material. Then I will be discussing the atomic structure. So you will be having the nucleus, then that nucleus will be surrounded by orbit, right? First shell, second shell, or first orbit, second orbit, and the last orbit we call it as valence orbit or the valence shell. So the electron that are part of this valence orbit or shell is known as valence electron. So I will be running through that one. Then on what basis, how many electrons will be there in each orbit, right? So all those things will be discussing. Then what is n-type semiconductor, what is p-type semiconductor, and so I will be getting that one. So that is a extrinsic semiconductor. Intrinsic semiconductor is one which is purest semiconductor, we call it as intrinsic, means there is no impurity added to that one. So extrinsic semiconductor is one wherein we will be adding some impurities to that one. So in order to form n-type, we will be adding some impurity to your semiconductor material. Then for p-type, we will be adding some other impurity to that one. So we will be discussing all those things. Then how this conductivity is happening in case of n-type and p-type. So I will start with the basic thing, that is review of semiconductor theory. So in this one we will be seeing the classification of materials, right? How these materials are classified. So this classification is based on the conductivity. So based on the conductivity of the material, we got three types of classification of this one. First one is conductors, second one semiconductors, and third one insulator. So this classification is based on conductivity of the material. So conductor, first one. So in conductor, what happens? The resistance offered by that material will be very less. Means the resistance to the flow of electron, right? So we know the definition of electric current, that is nothing but the flow of electron. So the resistance offered by that material to the flow of electron will be very less. So because of that, conductivity of these conductors will be very high. Example, copper, aluminum, these are the example for conductor. So next we will see what is insulator. Insulator means the resistance offered to the flow of electron by that material will be very high. So because of that, we can say there is no electric current flowing in the insulator. So example here you can give paper, wood, etc. Right? Then next one is semiconductor. So here semiconductor materials are those whose conductivity will be between that of insulator and conductor. The conductivity of the semiconductor will be between insulator and conductor. So example, silicon, then germanium, then gallium arsenide, right? So these are the example for semiconductor. So here we have to understand some important properties of semiconductor. One property just now I mentioned, the conductivity of the semiconductor will be between that of insulator and conductor. Another important property we have to remember for the semiconductor is that the conductivity of the semiconductor increases with increase in the temperature. So this concept we call it as negative temperature coefficient. But in case of conductor, when temperature is increased, the conductivity or resistance will be increasing. So that is the positive temperature coefficient. So that is the second property of semiconductor. And third property, you can enhance the conductivity of the semiconductor by adding some impurity to that one. So these are the few properties of semiconductor. First one, conductivity of the semiconductor will be lying between that of some insulator and conductor. And next one, conductivity of the semiconductor will be increasing with the increase in the temperature. And third one, you can enhance the conductivity of semiconductor by adding some impurities. So we'll be discussing this thing in details. Next we'll see the structure of an atom. So we know that atom consists of nucleus. So in nucleus we will be having neutrons and protons. So neutrons are positive charge, this thing. The protons are the positive charge. Neutrons are, they will not be having charge, but they will be having only mass. Whereas proton will be having mass as well as the charge. So this nucleus consists of protons and neutrons. Then it will be surrounded by electrons. So around nucleus we will be having some orbit. Shell 1 or orbit 1, shell 2 or orbit 2, shell 3 or orbit 3. In this orbit, electrons will be revolving. So the number of electron will be equal to number of protons in a given atom, right? So whereas this electron will be negatively charged and mass of these electrons will be very less. Because of that, they will be having high mobility, means they can move easily because of very less mass. So they say that the mass of electron, or you can say 1800 times the mass of electron equal to proton. So proton will be heavier. Proton and neutron will be heavier compared to electrons. So we will see this structure. We will take example of one silicon atom. So the atomic number of this silicon is 14. So atomic number of the silicon is 14, and we will be having this nucleus that consists of protons and neutrons. Then it will be surrounded by orbits or shell. First orbit, second orbit, third orbit, right? So here in this orbit we will be having some electrons, right? So in first orbit we will be having 2 electrons, in next orbit we will be having few electrons, in the third orbit we will be having some electrons. How this is calculated means using this one, 2n square, 2 to the power 2n square. So for n is equal to 1, so when n is equal to 1, here 2 into 1 square, that is 2. So number of electron in first orbit will be 2. So this is first electron and this is second electron, right? Then n is equal to 2. 2 into 2 square, that is 2 into 4, that is 8. So in second orbit we will be having 8 electrons. Then 8 plus 2, 10. Then out of 14, 10 are occupied in first orbit and second orbit, and remaining 4 will be in third orbit, that is valence orbit or shell. So electrons in this outermost orbit is known as valence electron, and orbit is valence orbit. So here this nucleus consists of protons and neutrons. So in this case, in case of silicon atom, it will be having 14 proton and 14 electron. They will be rotating in these 3 orbit. So in first orbit we got 2 electrons, in second orbit we got 8 electrons, and in third orbit or valence orbit we will be having 4 electrons, right? Another definition for intrinsic semiconductor is that semiconductor, the material that has got 4 valence electron in the outermost orbit, those material they will be calling it as intrinsic semiconductor, right? Similarly, you can take example of germanium also. So in germanium the atomic number is 32. So you can calculate that one. When n is equal to 1, in first orbit you will be having 2. When n is equal to 2, in second orbit you will be having 8. When n is equal to 3, you will be getting 18. So when 18 plus this 2 plus 8. So that will be 28. So 32 minus 28, 4. So in the fourth orbit, you will be having again 4 electrons. So that is the example of intrinsic semiconductor, because in the fourth orbit of this germanium atom, again we have got 4 electrons. So this is the structure of an atom. Next we'll see ionization. Okay, we'll see what is this ionization. So if an electron is removed from the outer shell of an atom, then the total negative charge will be reduced, because we will be removing one negatively charged electron, right? So that atom now becomes positive ion. The positive charge of that atom will remain same, because the positive charge, that is nothing but protons, they are part of nucleus. Here we are just removing one electron from the outer shell or the valence orbit. So because of that, total charge of that total negative charge of that atom will be reduced. So because of that, it will be becoming positive ion, means it will be losing its electrical neutrality. Then similarly we can say, by some means, if you add some atom to this one, electron to atom, then it will be increasing the negative charge, total negative charge of that atom will be increased. Then we call that as negative ion. So this process of changing atom from electrically neutral to positive ion, or atom from electrical neutral to negative ion, that process we call it as ionization. Then next we will see energy band. So again, based on this energy band also, we can classify this one materials like insulator, conductor, semiconductor. So here in energy band, we will be having different levels of energy. So here we should understand, electron in each orbit will be having some definite energy. Electron that are part of first orbit, it will be having some definite energy. Then electron in the second orbit, it will be having some definite energy. Then electron in the valence or outermost orbit, it will be having some energy. This energy level of electron will be increasing as we move away from the nucleus of the atom. Means in first orbit electron, they will be having less energy compared to the electron that are part of second orbit or higher orbit. So we can say energy of valence electron is highest or largest compared to other orbit electrons. So based on this, we will be drawing this diagram. So first orbit, some energy will be there. Then second orbit, that is energy band corresponding to second orbit. Then this is your valence band. Then you will be having the conduction band. So energy of this conduction band will be high, because it consists of free electron. So this is first orbit. Here this energy level is formed by merging the electrons that are part of first orbit. Just now I mentioned, electron in each orbit, it will be having some energy. So merging those energy together, we will be getting this one level. This is energy level corresponding to orbit 1. This is energy level corresponding to orbit 2. This is energy level corresponding to valence orbit or outermost shell. Then this is the conduction band. So this gap we call it as forbidden gap, right? So in order to move electron from this valence band to conduction band, the energy required for electron to move from this valence band to conduction band should be more greater than this forbidden energy band. So again, based on this, you can have this classification. In case of conductor, your valence band and conduction band will be overlapped. But in case of insulator, there will be a huge gap between this valence band and conduction band. So this gap will be around like 7 electron volt. So you'll be requiring huge energy for moving electron from valence band to conduction band. Then in case of semiconductor, the gap between this valence band and conduction will be of order like 1 electron volt. So we'll be requiring some less energy to make transition of electron from valence band to conduction band. So this is based on the energy band theory classification. So next we'll see why this silicon is mostly used compared to germanium in making of diode or transistor. Right? Just now we seen the structure of atom of silicon. So it has got 3 orbit, first orbit, second orbit, third orbit. But in case of germanium, it has got 4 orbit. So you can say the electrons in the fourth orbit of germanium atom is loosely coupled with that of nucleus. But in case of silicon, it has got 3 orbit. You can say they are tightly coupled with that of nucleus. So what happens at room temperature? The electron from this fourth orbit of germanium, they may be making transition to conduction band. So you can say instability will be there in case of germanium at room temperature. Because of this thermal temperature, some electron will be gaining energy, then they will be making transition to conduction. So because of that, silicon is mostly preferred in these devices. So that is the reason for why silicon is mostly used. Silicon happens to be 3 orbit this one, whereas germanium has got 4 orbit. So the fourth orbit in that one, electrons in that fourth orbit, they will be loosely coupled with the nucleus. So with small change in this energy, they can make a transition to conduction band. So at room temperature, it becomes unstable. So that is the reason why silicon is mostly preferred. Next we will see intrinsic semiconductors. Okay, we'll see the next intrinsic semiconductor. In the definition of this intrinsic semiconductor can be given as purest semiconductor material, means there is no any impurity added to this material. So those materials we call it as intrinsic semiconductor. So we'll see the crystal structure of an intrinsic semiconductor, that is silicon structure, crystal structure. So here silicon, in its outermost layer, it has got 4 electrons. So this is electron, valence electron, right? So maximum number of electrons that you can have in the outermost orbit or valence orbit is 8 electrons. So that is the limit given. So here this silicon atom, it will be sharing electrons with neighboring silicon atoms. Again this silicon atom, again in its outer orbit, it will be having 4 electrons. So it will be sharing those electrons with the neighboring silicon atoms. So this sharing we call it as covalent bond. So they will be forming this one bond. That bond we call it as covalent bond. Right. So these are the electron in the outermost orbit. Silicon, it consists of 4 electrons in the outermost orbit. This atom. Similarly, this atom has got 4 electrons in the outermost orbit. So they will be forming this covalent bond with the neighboring atom by sharing the electron. So this concept we call it as covalent bond. So at any given point of time at 0 degree Kelvin, there will not be any free electron in case of intrinsic semiconductor. So it will be acting as a insulator. So this is the structure of intrinsic semiconductor, in particular silicon. So we'll see the charge carrier in intrinsic semiconductor. So at 0 degree Kelvin, there will not be any free electron in this intrinsic semiconductor. But at room temperature, due to thermal energy, some of this valence electron will get some energy and they will make a transition to conduction band, or they will be moving randomly inside the crystal. Right. So when this electron is gaining some thermal energy, then it will be leaving this covalent bond. So this becomes free electron. But here it will be creating one hole here it will be creating one hole. So we can say that again this electron may get some energy and it will be breaking this covalent bond. Again this electron will be free now. So it will come out of that bond. Then it will be creating one hole here. So you can say this electron hole pair will be created in case of intrinsic semiconductor, means number of free electron will be equal to number of holes. So next we will see the extrinsic semiconductor. So extrinsic semiconductor we can define it as when you add some impurity atoms to your intrinsic semiconductor, then you will be getting this extrinsic semiconductor. Why we will be doing this one means in order to increase the conductivity of that semiconductor. So based on that we will be having two type of this one extrinsic semi. One is N type, another is P type. N type semiconductor and P type semiconductor. So we will be adding some impurity item to intrinsic semiconductor. So that will be getting this extrinsic semiconductor. So two types, N type and P type. So the atom that will be adding to this intrinsic semiconductor we call it as impurity items or dopant we will be saying, right? So we will be calling it as dopant. We will be doping some impurity item to this intrinsic semiconductors. So in order to form this N-type semiconductor, we will be adding pentavalent atom. Pentavalent atom means in the valence orbit or in the outermost shell, it will be having 5 electrons. So if you add these 5 electrons to intrinsic, so one property I told, intrinsic semiconductor, it will be having 4 electrons in the outermost orbit, right? So when you add pentavalent atom to some intrinsic semiconductor, say silicon, so you will be having 4 electron in the outermost orbit of silicon, but this impurity atom, which has got 5 valence electron in the outermost orbit. So 4 atoms of this silicon will be forming this covalent bond with the 4 atoms of the impurity atom, but there will be 1 electron extra, that is will be added to your semiconductor. So if you add, the conductivity will be depending on the number of impurity atom you are adding. So that is the N-type semiconductor. For P-type semiconductor, we will be adding trivalent atom to intrinsic semiconductor. So trivalent means the atom will be having 3 electrons in the outermost orbit. So same silicon and trivalent impurity is added to that silicon atom. So we know silicon has got 4 electrons in the outermost orbit, and this impurity atom, that is pentavalent, trivalent, it has got 3 electrons. So 3 electrons of this impurity atom and 3 electrons of silicon in the outermost orbit, they will be forming the covalent bond. But there is a this one hole, means 1 electron will not be forming the covalent bond because you got only 3 valence electron in the outermost. Because of that, there will be a hole created because there is a requirement of electron. So because of that, there is a hole. So that will be helping us to form this P-type semiconductor. So that's all for this session. So in next session, we will be discussing further topic. Thank you.